Deep beneath the sparkling turquoise waters of the Mediterranean Sea, something massive is stirring. While tourists lounge on the sun-drenched beaches of the Greek islands and fishing boats bob peacefully in the surf, a silent giant is waking up from a slumber that has lasted for centuries. Far below the seabed, hidden from human eyes, but captured by the most advanced sensors on the planet, a magma chamber is inflating at an incredible rate. This isn't just a minor geological hiccup. We are talking about a colossal reservoir of molten rock that is filling up right beneath one of the most historically significant and densely populated regions on Earth. Scientists who have spent their lives studying the pulse of our planet are now sounding the alarm, and the data they are seeing is unlike anything recorded in modern Mediterranean history. For a long time, we thought we understood the volcanic landscape of southern Europe. We knew about Vesuvius, the charcoal-shadowed giant looming over Naples. We knew about Etna, the persistent fire breather on Sicily. But the real threat might be lurking in a place many would never suspect: the underwater volcano of Colombo. Located just a few miles off the coast of the world-famous island of Santorini, this submerged monster is proving to be far more active and far more dangerous than previously imagined. Recent breakthroughs in high-resolution seismic imaging have allowed researchers to peer through the Earth's crust like an X-ray, and what they found has sent shockwaves through the scientific community. A previously undetected magma chamber roughly 2 kilometers wide is ballooning with molten material. To understand why this is causing such a frenzy in the world of geophysics, we first have to look at how these systems work. Magma chambers are essentially the lungs of a volcano. They inhale molten rock from deep within the mantle, expanding as pressure builds up. For decades it was assumed that Colombo was relatively quiet, a relic of past eruptions that didn't pose an immediate risk. But the new data tells a different story. The chamber is growing at a rate that suggests a high level of thermal activity. Every year, millions of cubic meters of magma are being injected into this subterranean pocket. This isn't a slow geological crawl that takes millions of years. This is happening on a human timescale. Right now, as you watch this, the Mediterranean has always been a tectonic jigsaw puzzle. It is the place where the African plate and the Eurasian plate engage in a slow-motion collision. This subduction zone is the ultimate engine of destruction and creation. As one plate slides beneath the other, it drags water and sediment deep into the hot interior of the Earth. This lowers the melting point of the surrounding rock, creating the very magma that is currently filling the Colombo chamber. But why now? Why is this specific spot suddenly becoming a focal point for such rapid growth? That is the multi-billion-dollar question that researchers are racing to answer. When we talk about volcanic risks in this region, people immediately think of the Minoan eruption of Santorini around 1600 BC. That event was one of the largest volcanic incidents in human history, potentially altering the course of civilizations and inspiring the legend of Atlantis. While Colombo is a separate volcanic system from the main Santorini caldera, they are inextricably linked by the same plumbing system deep underground. The fact that a secondary vent like Colombo is showing such intense signs of inflation suggests that the entire magmatic complex under the Aegean Sea is entering a new phase of unrest. Scientists are particularly concerned because Colombo is a submarine volcano. You might think that being underwater would dampen the effects of an eruption, but it actually makes things much more complex and potentially more hazardous. When magma at over 1,000 degrees Celsius meets seawater, the result is a massive steam explosion. This process, known as fuel-coolant interaction, can trigger tsunamis that would radiate outward, hitting the shores of nearby islands within minutes. Imagine a wall of water traveling at the speed of a jet plane, triggered by a blast that happened miles offshore and hundreds of meters deep. This is the scenario that keeps disaster planners up at night. The technology used to discover this growing magma chamber is a feat of modern engineering. Researchers utilized a technique called full waveform inversion. By using acoustic waves to map the sub-bottom structures, they can create a three-dimensional map of what lies beneath. In the past, our maps were blurry and imprecise. But this new method provides a crystal-clear image of the boundaries of the magma body. They can see exactly where the molten rock ends, and the solid crust begins. What they saw was a reservoir that had reached a critical state of overpressure. Pressure is the key metric here. Think of a balloon being inflated. You can keep adding air for a long time, and the balloon just gets bigger. But eventually, the tension on the rubber becomes too much. The Earth's crust acts like that rubber. It can stretch and deform to a certain point, but once the pressure from the magma exceeds the strength of the overlying rock, something has to give. The rapid rate of inflation at Colombo indicates that we are moving toward that breaking point much faster than anyone predicted 10 years ago. Another alarming factor is the depth of the chamber. It is located just a few kilometers below the seafloor. This is considered very shallow in geological terms. A shallow magma chamber means that the path to the surface is relatively short. There is less rock to act as a lid, and any breach in the reservoir could lead to a rapid ascent of magma. This increases the likelihood of a violent explosive event rather than a slow, oozing lava flow. The mineral composition of the magma in this region also tends to be high in silica, which makes it viscous and prone to trapping gases. When that gas-rich magma finally reaches the surface, it doesn't just flow, it explodes. But it's not just about the magma. The area around Colombo is also home to a series of hydrothermal vents. These are like chimneys on the seafloor that spew out superheated water enriched with minerals and gases like carbon dioxide and methane. These vents are a clear sign that the heat source below is intense. In recent surveys, ROVs or remotely operated vehicles have filmed these vents in action. They found strange alien-like ecosystems thriving in the heat, but they also found evidence that the chemistry of the water is changing. There is an increasing concentration of acidic gases, which is a classic precursor to increased volcanic activity. It's as if the volcano is exhaling, warning us of the buildup happening deep in its throat. The international community has stepped up monitoring efforts significantly. There are now sensors on the seafloor that measure every tilt, every tremor, and every change in temperature. We are basically giving the volcano a constant EKG. The challenge is that we have very little historical data for submarine eruptions of this scale. We know what happened at Vesuvius, because people were there to write it down. But an underwater volcano can grow and stir for years without anyone on the surface noticing until it's too late. This new study is a wake-up call that we need to be looking down just as often as we look up. Why does this matter to you, even if you don't live in Greece? The Mediterranean is a hub of global shipping, fiber optic internet cables, and energy pipelines. A major geological event in this corridor could disrupt global trade and communication in an instant. Furthermore, the climate impact of a large-scale explosive eruption can be global. Volcanic ash and sulfur dioxide injected into the upper atmosphere can reflect sunlight, leading to a temporary cooling of the planet. Which sounds like a good thing in an era of global warming, but in reality, it causes massive agricultural shifts and weather anomalies that can lead to food shortages. The scientists involved in the study emphasized that an eruption isn't necessarily imminent tomorrow or next week, but the trajectory is clear. The system is recharging. In the world of volcanology, recharging is a word that describes the process of fresh magma moving into a system after a period of dormancy. Colombo has had several quiet centuries since its last major event in 1650. During that 1650 eruption, the volcano actually breached the surface of the sea, creating a temporary island and releasing toxic gases that affected people and livestock on Santorini. That event was devastating, and the current magma chamber is already reaching sizes comparable to what was present back then. What's fascinating is how the local geography plays into this. Santorini itself is essentially the rim of a giant volcanic crater. The beauty of the whitewashed houses perched on the cliffs is a direct result of past volcanic violence. People live on the edge of a literal powder keg because the soil is fertile and the views are breathtaking. But the growing magma chamber at Colombo reminds us that the earth beneath our feet is far from stable. It is a living, breathing entity that operates on a cycle far longer than human memory. Researchers are now using supercomputers to run simulations based on the new seismic data. They want to know exactly how much more magma the chamber can hold before the roof collapses or the sides burst. These simulations take into account the weight of the water above, the density of the rock, and the viscosity of the magma. Every time they plug in new numbers, the results point toward a system that is becoming increasingly unstable. The rate of magma influx is currently estimated to be significantly higher than the average rate recorded over the last several centuries. This rapid loading of the system is the primary reason for the alarm. One of the most chilling aspects of the discovery is the silence of it all. If a volcano on land were inflating this much, we would see cracks in the ground, roads buckling, and steam rising from the hills. The signs are invisible to the naked eye. Without the dedicated work of marine geologists and their specialized equipment, We would have absolutely no idea that a massive pool of molten rock was expanding right next to one of the world's most popular vacation spots. It's a testament to the importance of basic scientific research. We are literally mapping the dangers of the future before they arrive. The study also highlights a gap in our defenses. While we have early warning systems for tsunamis caused by earthquakes, we are much less prepared for tsunamis caused by volcanic explosions. The physics are different, and the warning times can be even shorter. If Colombo were to erupt tomorrow, the displacement of water could hit the northern coast of Santorini in less than 2 minutes. That is nearly zero time for a coordinated evacuation. This realization is forcing local authorities to rethink their disaster preparedness plans, focusing more on long-term monitoring and automated alerts. But it's not all doom and gloom. This discovery is a massive win for science. By identifying the magma chamber now, we have a window of opportunity. We can study the precursors, learn the patterns, and perhaps find ways to predict the exact moment of failure. This is the first time we've been able to track the growth of a submarine magma chamber with such precision. It's like having a front-row seat to the most powerful show on Earth. The data gathered here will be used to better understand volcanoes in the Pacific, the Atlantic, and everywhere else where fire meets water. The magma itself is a fascinating subject. It's not just melted rock. It's a complex soup of chemical elements under extreme pressure. As it moves upward, it picks up minerals from the surrounding crust, changing its flavor. By analyzing the gases coming off the hydrothermal vents, scientists can actually tell where the magma is coming from and how long it has been sitting in the chamber. The current chemical signature suggests a fresh batch of magma coming straight from the mantle, which is usually hotter and more energetic than stale magma that has been cooling in the crust for a long time. This adds another layer of concern to the rapid growth of the chamber. Another mystery scientists are trying to solve is the intermittency of the growth. Does the magma flow in a steady stream, or does it arrive in pulses? The evidence seems to suggest pulses. This means there are periods of extreme activity, followed by periods of relative calm. We might be in the middle of a major pulse right now. If the pulse continues, the pressure could reach critical levels much sooner than expected. If it tapers off, we might have another few decades of quiet. The problem is, we don't know which phase we are in until it changes. The Mediterranean region is a cradle of civilization, and geology has played a huge role in that. The same forces that create the danger also create the beauty and the resources that have supported people for 5,000 years. The volcanic ash makes the soil incredibly rich for vineyards and orchards. The thermal activity provides potential for clean geothermal energy. But the price of living in such a dynamic place is constant vigilance. The discovery of the Colombo magma chamber is a reminder that the lease we have on our land is signed by a very temperamental landlord. As we move forward, the focus will be on even higher resolution monitoring. There is talk of laying permanent fiber optic cables on the seafloor as part of a smart observatory. These cables can act as thousands of tiny microphones, picking up the faintest whispers of the magma moving below. This would give us a real-time, high-fidelity stream of data that could save lives. It's an expensive undertaking, but compared to the cost of an unannounced eruption, it's a bargain. When we look at the global context, the Mediterranean isn't alone. There are hundreds of submarine volcanoes around the world that we know almost nothing about. The techniques developed to study Colombo will be applied globally, likely revealing many more hidden magma chambers that are currently growing under our oceans. We are entering a new era of oceanography, where we don't just look at the water and the life within it, but also at the engine rooms of the planet that lie beneath the crust. What makes the Colombo study so special is the collaboration between different scientific disciplines. You have seismologists working with geochemists, marine biologists, and computer modelers. It's a holistic approach to understanding a complex problem, trying to piece together a narrative of what is happening in the darkness. And the narrative they are constructing is one of a system that is rapidly approaching a phase change. The transition from a growing chamber to an erupting one is the most dangerous moment in geology. Scientists have also been looking at the seismic history of the surrounding islands. They found that in the months leading up to previous small events, there was a specific pattern of microquakes. These are tiny tremors that humans can't feel but that indicate rock is cracking as magma pushes through. The current data shows an increase in these microquakes around the Colombo site. It's like the sound of a house settling, but on a massive, geological scale. Every little crack is a sign that the magma is winning the battle against the rock. The impact on the local community is a sensitive issue. Santorini relies heavily on tourism, and news of a growing magma chamber can be frightening. However, the goal of the researchers isn't to cause panic, but to provide the knowledge necessary for safety. Knowing is always better than not knowing. By understanding the threat, the local government can build better infrastructure, create effective evacuation routes, and educate the public on what to do if an event occurs. Modern science is the ultimate tool for resilience. As we dive deeper into the data, we also see the role of magmatic overpressure. This is a state where the pressure inside the chamber is significantly higher than the weight of everything above it. Usually, these two forces are in balance, but the rapid rate of inflation at Colombo suggests that this balance has been lost. The chamber is actively pushing against its surroundings, trying to expand its territory. This displacement of rock can be measured in centimeters from space, using satellite radar, and the results confirm what the underwater sensors are saying. The ground is rising. Think about the sheer volume of material we are talking about. Millions of cubic meters of molten rock. To put that in perspective, that's enough to fill thousands of Olympic-sized swimming pools every single year. All of that heat and energy is concentrated in a tiny spot on the map. It's a localized point of intense geological power. The Mediterranean is often seen as a gentle, enclosed sea, but discoveries like this remind us that it is just as wild and untamed as the deep Pacific. The researchers also point out that the magma chamber isn't just a simple pool. It's more like a sponge, a crystal mush, where liquid magma is interspersed with solid minerals. The way this mush behaves is incredibly complex. If fresh, hot magma enters the mush, it can remobilize it, turning a semi-solid mass into a liquid very quickly. This can lead to a sudden and dramatic increase in pressure. This defrosting of the magma chamber is one of the scenarios the scientists are most concerned about, as it can happen much faster than the gradual accumulation of new magma. In the coming years, we will likely see more expeditions to the Colombo site. Scientists want to take core samples of the seafloor to see how the sediments have been affected by the rising heat. They want to deploy more gas sniffers to track the composition of the hydrothermal plumes. Every bit of data is another piece of the puzzle. We are trying to build a predictive model for an event that hasn't happened yet, using clues from a deep, dark environment that is incredibly difficult to access. This discovery also changes how we think about volcanic dormancy. Just because a volcano hasn't erupted in 300 years doesn't mean it's finished. It just means it's on a different clock. The human lifespan is a blink of an eye to a volcano. What looks like a peaceful mountain or a quiet patch of sea can be a system in the middle of a massive recharge cycle. Our challenge as a modern civilization is to adapt our short-term thinking to these long-term geological realities. The magma chamber under the Mediterranean is a reminder of the power and the mystery of our planet. Even in a world where we can map every street and see every building from space, there are still massive earth-shattering processes happening just out of sight. The work of the scientists at Colombo is a shield, providing us with the foresight to protect our communities and our way of life. They are the watchers on the wall, keeping an eye on the fires of the earth, so that we don't have to. The alarm they are sounding isn't a call to fear, but a call to action. It's a call to invest in science, to respect the power of nature, and to stay curious about the world around us. The Mediterranean magma chamber is growing, and while that is alarming, our ability to detect it and study it is a triumph of human ingenuity. We can see the magma, we can measure the pressure, and we can prepare for whatever comes next. As we keep a close watch on Colombo and the waters of the Aegean, we are reminded that the story of our planet is still being written. It's a story of constant change, of heat and pressure, and of the incredible resilience of life in the face of geological giants. The fire below is a part of who we are, a part of the history of the Mediterranean, and a part of our future. Stay tuned as we continue to monitor this developing situation and bring you the latest discoveries from the frontiers of science. The more we know, the better prepared we are for the incredible world we live on. Scientists continue to analyze the data from the most recent seismic surveys, and the picture that is emerging is one of undeniable intensity. The magma reservoir is not just growing, it is evolving. The boundaries of the chamber are becoming more defined, and the thermal gradient around it is sharpening. This means the heat is becoming more concentrated, which can lead to further fracturing of the surrounding rock. Each new report adds a layer of urgency to the international monitoring effort. Another fascinating element being studied is the potential for triggering. Could an earthquake in a nearby fault line provide the final nudge that causes the magma chamber to breach? The Mediterranean is a seismically active zone, and the relationship between earthquakes and volcanic eruptions is a major area of research. A significant tremor could act like a hammer blow to an already overpressurized container. Understanding this link is crucial for creating accurate risk assessments for the entire region. In the end, the discovery of the rapidly growing magma chamber at Colombo is a testament to the fact that we live on a dynamic and ever-changing orb. The Mediterranean, for all its history and beauty, is a place where the deep forces of the earth are constantly at work. We are guests on this planet, and part of being a good guest is paying attention to the signals the earth is sending us. The alarm has been raised, the sensors are active, and the world's best minds are on the case. We will continue to watch, to learn, and to marvel at the sheer scale of the power that lies beneath the waves. The ongoing research into Colombo is a perfect example of why we can never stop exploring. Just when we think we've mapped everything, the Earth reveals a new secret, a new challenge, and a new opportunity to learn. The molten rock below may be growing, but so is our understanding of how to live in harmony with a volcanic planet. Every day we get a little bit better at reading the signs, and every day we become a little bit more resilient. The Mediterranean magma chamber is a giant, yes, but it's a giant we are finally starting to understand. This scientific journey is far from over. As technology continues to advance, we will get even closer to the heart of the volcano. We will see the magma move in real time. We will understand the chemistry of the deep earth like never before. And we will turn our alarm into a sophisticated, life-saving awareness. The story of Colombo is the story of modern geology, a blend of high-tech detective work, deep time perspective, and a commitment to protecting the future. It's an incredible time to be watching the Earth, and we will be right here to bring you every update from the front lines of discovery. Stay curious, stay informed, and always keep an eye on what lies beneath the surface.